Okay, today is May 19th, 2011. We're on textbook page 395 and Blue Notebook page 335. We're going to skip lesson 7.1. It's just investigating data. We're going to go straight to 7.2, which is the laws of exponents. So you guys for sure would have learned this in grade 9, possibly elementary school. I need you guys to remember this. So, first law, x to the power of a times x to the power of b is equal to x. Anyone know what I do with those exponents? No? You add them. Very good. I take a plus b. Okay? That's our multiplying rule. Okay? That's our law of multiplication of exponents. If I'm to divide exponents, so exact same setup, x to the power of a divided by x to the power of b is equal to x a minus b. And finally, x to the power of a to the power of b. You multiply those, so it's xa times b. This is the power rule. So these will be our rules. There are 3 different types of rules. If you're multiplying two numbers where the base is the same, you can just add their exponents. If you're dividing two numbers where the base is the same, you subtract the exponents. And if you have a number to the power of another power, you multiply the exponent. So what I mean by the base is the same is, if you guys notice, I have x in both of these. If I have 5 to the power of 1 and 4 to the power of 2, I cannot just add the exponents. The base has to be the same. So in other words, I could have 5 to the power of 1, 5 to the power of 2, add the exponents, 5 to the power of 3 would be the answer. Okay? Same thing goes with division. Bases have to be the same. And finally, there's only one base in the power rule. Okay. Okay. All right. Question for Tom. There you go, Tom. Take a second. All right, Ian. First step, we deal with the top. So what happens to the top? It's going to become 6 over 8. Why? What is this 6 to the power of? That's right. Technically, there's a 1 there. So this says 6 to the power of 1 times 6 to the power of 7. So we add those exponents. 1 plus 7. The top is the equivalent of 6 to the power of 8. Now, second part. I have 6 to the power of 8 divided by 6 to the power of negative 2. According to this rule, what do I have to do? Ian. I don't need to flip it yet. I can just stick to the rule on this one, but you're right. Sorry. Anyone have an answer for that? Okay. How did you get that? Okay. So we have to subtract the exponents, 8, subtract negative 2. And we know that's going to end up being 6 plus 2. So our last answer there is 6 to the power of 10. I'm pretty sure that was example 3 on today's work. Oh, no, it's a little different. Okay, and finally, if I ask you to evaluate that, and finally, if I want to evaluate that, okay, on your calculator, you'll have a button that looks like this, hopefully. Almost looks like the roof of the house. That will turn the first number you put into the base, and then the next number I put in will be the exponent. So this says 6 to the power of 10. 6 to the power of 10. There's our answer. So, 604666176 So the number is 60,466,176. Example number 2. What this actually means is I'm taking that bracket and multiplying it by itself 3 times, since it is to the power of 3, the bracket. So in other words, if I were to do this the long way, this would say 5x cubed y to the 4th times 5x cubed y to the 4th times 5x cubed y to the 4th. Okay? Or we can do this the quicker way. We need to multiply all of the exponents. So instead of playing out this long expression, I'm going to bring the 3 inside the brackets. Now 5 is to what exponent? Technically there's a 1 there. So many of you when looking at this may just leave the 5 because it's not a variable. It's still a number that we have to bring the number 3 and multiply it by its exponent. So since 5 is technically to the power of 1, that's 1 times 3. The x is another number. It's to the power of 3. And since this is a power of a power, we multiply it by our outside 3 again. And finally, y is to the power of 4. And we multiply it by the power of 3. This is like distributive. So, in other words, I had the power of 1. I multiplied 3 times 1. This one was the power of 3. I multiplied 3 times 3. And this is the power of 4. I multiplied 3 times 4. So, our final, after we've evaluated the exponents, we'll have 5 to the power of 3, x to the power of 9, y to the power of 12. I can still simplify this farther. 5 to the power of 3, 125. Very good. 125 times x to the power of 9 times y to the power of 12. So even though the original laws we learned about 10 minutes ago are very straightforward, the difficulty is applying them. You have to follow BEDMAS when doing this. Technically, when I looked inside of this bracket, I should have tried to simplify in there. I can't. We have the number 5, a coefficient, a variable, and a different variable. So technically, this bracket is as simple as it gets. The next step is to deal with the exponent. And when dealing with the exponent, since our power rule, we multiply it by each of the powers inside the brackets. Makes sense. I'll repeat that. So if we look at this part here, where I've written the base out 3 times, because technically this bracket is just the base to the power of 3, so we write it out 3 times. I'm going to give you a quick, this is technically the multiplication rule also. Even though we did it the fast way by using the power rule, by multiplying it by each of the exponents. First we'll deal with the 5. 5 times 5 is 25, times 5 is 125. The next part here is I technically have x to the power of 3 times x to the power of 3 times x to the power of 3. When I have the same base multiplied by each other, what do I do to the exponents? Anyone remember from that law, the multiplication rule? You add them. So 3 plus 3 is plus 3, x to the power of 9. And finally, this says y to the power of 4 times y to the power of 4 times y to the power of 4. Same rules before, it's multiplication. We add them. 4 plus 4 is 8, plus 4 is 12. So the fast way to do this was just using the power rule. But you could have rewrote it this way and used the multiplication rule to solve this question also. Finally, our third example. This one is much more complicated. Okay? So this is where we need to follow our rules of BEDMAS in order to solve. V-E-D. I hope you know how to spell BEDMAS. Otherwise, you're going to be in trouble. So, we're going to deal with individual brackets first. This bracket, our first one, I look inside it. I cannot simplify anything in the brackets. Our variables are different and our coefficients are different. I can't simplify any of this. So I can't deal with this bracket. I go to the second one. Same idea. Different variables, different coefficients. Brackets are done. There's nothing I can do in there. Next step is exponents. It makes sense that I can do something with the exponents since we're on the exponent chapter. So, I'm going to deal with just the first one, okay? We're going to deal with just the first bracket. Technically, this bracket, think of it as the base once again. So this is the base to the power of 2. So I could rewrite the base twice. I could rewrite this as 3x cubed over 2y4 times, oh, what happened there? Times 3x cubed 2y4. And then technically times our other bracket, we got to make sure we bring it down. Just doing one at a time. So what I've done is, since this is to the power of 2, I've duplicated the base twice. The other way we could have done this, anyone know? Could use the power rule. I'm going to use the power rule below, okay? Then I'll talk about how the multiplication rule gives us the same answer. So technically, this is 3 to the power of 1 and 2 to the power of 1. So when I rewrite this as a power rule, it's 3, 1 times 2. We multiply the exponents. X3 times 2 over 2, 1 times 2. And Y4 times 2. This is our power rule. So what I've done is I've distributed this power of 2, and I'm multiplying it by all of the exponents inside of the brackets. That's our power rule. Remember, that's the third one I showed you. I'm not going to do anything to the second bracket yet. I'm going to do this one at a time. Okay? This is our, yeah, I can think of it as a third step. Yeah, I could go to this. I could technically skip this second line here and go straight to this one if we wanted. Okay? It's up to you. So when I write these out, this becomes 3 to the power of 2, x to the power of 6, y to the power of 2, y to the power of 8. Okay? I'm going to leave them as exponents because I'm going to try to keep going with my exponent rules. Now, I know that I could duplicate this base 3 times. This would be our second step here because it's the power of 3. But instead, I'm just going to apply the power rule again. So this is 2, technically to the power of 1, times 3. We're bringing the exponent in. Y to the power of 2 times 3 above 3, power of 1 times 3, and x to the power of 4 times 3. We're just going to use the power rule to solve this. So I bring down my other bracket again, 3 squared, x to the 6th, 2 squared, y to the 8th, 2 cubed, y 6, 3 cubed, x 12. So now I've dealt with all of the exponents. Ooh, I'm out of time here. I've dealt with all the exponents. Technically, this is a multiplication question, and I can multiply the fractions. So what I'm going to do is technically we multiply the top by the top, bottom by the bottom. I'm going to combine them all into one line. So what this is going to say is 3 squared times x power of 2, 2 to the power of 3, y to the power of 6. As you notice, I haven't actually changed any of the numbers. I just brought them all together. I'm going to do the same to the bottom. And I'm going to try to line them up with what we had. So technically my base 3 is base to the power of 3. My x was to the power of 12. My 2 was to the power of 2. And my y was to the power of 8. I've lined them all up with the same basis so that we can apply our division rule to this. If you remember division rule, we could just subtract the exponents. So the first one, the power of 3, what is 2? Subtract 3. Negative 1. So 3 becomes to the power of negative 1. Our x, x6 subtract 12 gives us negative 6. So it's x to the negative 6. Our 2 is power of 3 subtract 2 gives us just 1. So it becomes 2 to the power of 1. And finally, our y is 6 subtract 8 is negative 2. So y to the negative 2. So technically, this is our answer here. The only other thing Okay, so to turn these exponents to positives, I just put them on the other side of the fraction. So 3 is on the bottom, x is on the bottom, y is on the bottom, and this would be our positive exponent answer. Okay? All of the answers have positive exponents.